Wow, we're live. Oh my gosh. I was sort of went into a trance with that music. It was very
I know. Awesome party mode. I'm just
going into a zen place. Yes, in my happy place. So welcome all of you who are tuning in via various social media channels, and welcome to our Slam fam at the Happy Raven. You are all experiencing what is about to be the 2022 SciComm Conference Science Slam. And I'm especially excited to welcome my co-host, Darrion Nguyen. Let me see if I point that way. Yes, he's over there. Okay, I got it right. Who has, you may know him from Lab Shenanigans, and he has been called by someone important. I can't remember who, but they were right. The Bill Nye of millennials. Who called you that, Darrion?
Oh gosh. It was a journalist. I don't remember who, but yes, a journalist.
And I have called myself off-brand Allie Ward. So
yes, I saw on your Twitter. I saw.
Yes. So far, I don't think anyone else has called me that. I think that's just a me thing. But maybe if I changed my Twitter handle to off-brand Allie Ward. We love you, Allie, host of the podcast Ologies. So yes, I should wish to someday be off-brand Allie Ward. But so I'm delighted to welcome you, Darrion. Have you ever been part of a science slam before?
Thank you. No, I've never. So I'm so happy to be losing my science slam virginity to y'all.
No, just to me. No. I can't be possessive. I have to share Darrion with everyone.
We get it. You have possessive issues. We get it. It's okay.
Well, it was established actually last night when you gave your keynote talk for SciComm that you and I are the same person. I don't know what that means for a potential romance between us. I don't know. Then it's just like no, I'm not going to go that way. I promise to keep this PG-13, so we won't take it down that road. But we discovered that we are both Libras.
Mm-hmm.
That we both play viola.
Wait, how long did you play for?
Let's see, I started in 5th grade.
Shut the front door.
And we both learned the 50 States song in 4th grade.
Yes. Oh my! I swear we live the same lives.
I'm gonna have some questions for my mama, because we're separated at birth. We're gonna have a talk, but yeah. So we're the same person. So I'm co-hosting with myself, Darrion Nguyen, and I'm super excited that he is joining us, as well as all of you from the Happy Raven. Can we get our Slam Fam cam? There it is. Excellent. There they are. Excellent in-person watch party happening and at the Happy Raven in Lincoln, Nebraska. So people are going to enjoy their drinks and cheer on the slammers. Fantastic. Welcome to you all. We'll be shooting it to the Slam Fam cam intermittently throughout the program. Speaking of which, let me tell you a little bit about what a science slam is and what this particular science slam is all about. So the Science Slam concept originated in Germany, actually, in like 2006, and it was brought to the United States and to the fine state of Nebraska by my favorite German, Axel Enders. I don't know if he is watching anywhere. He's in Bayreuth now, and a few of the people who are slamming here today know him. He also taught me to swear in German, so wherever you are, Axel, Scheisse. And so he brought the Science Slam concept to the US. I believe that the University of Nebraska, believe it or not, was the first event of its kind, the first Science Slam in the US. And if you were familiar with poetry slams, then you're not too far off the mark when you think of what a Science Slam might be. Scientists aren't always necessarily encouraged to present their work in like a really fun way, even though science itself can be super fun. You can see, if you're a fan of Darrion's, why he was the natural co-host for the Science Slam, because science is fun is his motto, and middle name, if science is fun, could be a middle name.
That is true. It's on my birth certificate. How'd you know?
Because we're separated at birth. So
true. Oh my duh.
On my birth certificate too. So he's a perfect co-host for this. And it's actually a science communication competition. So here's where it's different from other competitions, like a lightning talk competition or elevator pitch competition that people might have been involved in before. And that is that you all, as in the people watching, get to vote to decide the winner. So a lot of times when scientists do these competitions, there's a panel of expert judges who get to decide. And so in a way, they're not really accountable for what they put in their talks. They're like, maybe people won't know what this means, but I like it, so I'm going to put this slide in, even if they don't know. I like it, so I'm going to put it in there. But you're really held accountable to Science Slam, because if people do not like your presentation, if they do not understand what you're talking about, they are not going to vote for you. If you do not make it fun, they are not going to vote for you. And the stakes are high as well, because it's not just, eternal internet glory and fame that awaits the winning slammer and all of the slammers, but $1,000 prize. So, and a bragging rights on their CV, of course. So they can put that they were the winner of the inaugural SciComm conference Science Slam. And so I'm excited about this because we've had in-person slams at the University of Nebraska before, but that were, sort of public audiences, but never with as wide a reach and as truly diverse an audience as we can have by streaming via social media. So this is pretty rad. Now, while no doubt you have not been listening to me, but reading the hilarious comic that is being displayed next to me, and who could blame you, because Strange Planet by Nathan W. Pyle is amazing. And this comic actually that's being displayed next to me actually inspired the prompt for the Science Slam. So this is another thing that's kind of unique about Science Slam versus other kinds of science communication competitions. And that is that we encourage people to tell us a story and frame your science as a story and not just as a research talk. And to do that, we usually provide a prompt. And the prompt this year was inspired by this excellent comic in which we have the small alien at a science fair talking about how he formed an idea, or she formed an idea, they formed an idea and discovered that they were wrong. And then the grown-up alien says there are numerous diagrams, and small alien says, I was wrong in numerous ways. I produced a detailed tribute to my wrongness. And then the conclusion is, that is science. And every scientist that I know looks at this and is immediately like, yes, that is science. Being wrong and producing a detailed tribute to your wrongness is absolutely what science is all about. But I think it gets a little trickier when we try to explain that to people who aren't and don't have experience being active in science, because they're like, well, if I'm wrong a lot, am I a scientist? Like, it's like the Einstein fallacy. People are like, Einstein failed math and he was a genius. I failed math, therefore I'm a genius, So like, what's the difference between scientists being wrong or science being wrong? And those are two different things maybe that we could talk about, but and just a regular person being wrong. And what role does wrongness play in science? So we're getting very philosophical here. We're asking the slammers to share about a time that they were wrong in science and how it helped them grow as a researcher and as a person, what they learned, and what that has to say about the role that being wrong plays in science. So I got to throw it to Darrion now. Have you ever been wrong, Darrion?
Funny story, I've never been wrong in my life, ever. I've always been right.
Pretty much what I think. You couldn't even finish that sentence with a straight face, could you?
It's funny because I was talking to my videographer today about being wrong with my brother growing up. We had a huge argument. This is totally unrelated to science, but growing up, I thought the correct way to pronounce mic, like M-I-C, like microphone, was Mick. And my brother, who's 7 years older than me, he was like, no, like, you're an idiot. It's Mike. And I was so adamant. I didn't want to be wrong. And so I kept I kept trying to push, like, no, it's actually pronounced mix. So just letting you know that. And yeah, I was just really stubborn at the time. This was when I was like 6, by the way. So yeah.
So you're not like, to this day, you're like, mic drop, you know, they're really amazing and funny. Yeah.
I actually cringe every time when I say Mike. So Mike. So I guess I was wrong in that moment, but it's whatever.
Yeah, stubbornness is the struggle is real. I totally get it. I think one of my mispronunciations that I was really stuck on was somewhere I got in my head that instead of obvious with a B, it was obvious with a D. And I'd be like, oh my gosh, it's so obvious. And it was really hard for me to make the switch. I don't know, something about odd. I just liked odd being in there. I related to it somehow. So how about a time in science when you were wrong? Have you any memorable mishaps in the lab?
When I was wrong, I think oftentimes, like when we're doing separate experiments and my team and I were trying to like hypothesize the mechanism of something. And I think sometimes we can be very adamant about our own hypotheses. And so I think to this day, I still think that my hypothesis for something is but that's why we have to keep doing more experiments to uncover the truth, you know? So
right. When the science changes, it doesn't mean that, you know, something's wrong. It means that the science is continuing. In fact, I would say individual scientists aren't necessarily this way, but science as like an emergent property that happens when you have a community of scientists is maybe one of the only enterprises where people actively tries to prove itself wrong. So any individual may not exactly want to be proven wrong, but science as a whole totally encourages you to go out and, you know, figure it out and prove it wrong.
Oh yeah.
So I'm excited to dive into hearing some of these stories from our times that they were wrong and what they learned. But okay, so first up, just a reminder for the slammers, and just so that everybody else can see my cute little people. The slammers are gonna have 5 minutes. Each slammer has 5 minutes to tell you about when they were wrong and what they learned. And so slammers, you won't see me do this, but I'm gonna hold up when you have 2 minutes left. This is Rosie. She's a neuron. I like to think she's a rose hip neuron, which is a newly discovered kind of neuron, an inhibitory neuron, which I could use a little inhibition every now and then, more so than I maybe have. So she's my sidekick. She keeps me in check. And when you see Rosie, think about what you still need to say because you have 2 minutes remaining. And then when you have 1 minute remaining, Emmy Moo Harris, the little cow, will appear. I'm going to hold her up. And when you see Emmy, then you know that you need to move it along because you only have 1 minute left. I have a story about this real quick before we get into the slam proper. We're going to talk about a lot of science, but we're also going to talk about other stuff because we like science, but we also like stuff. Am I right, Darrion?
You are so right.
You're pro stuff.
When you held up the neuron, I just realized I have a heart from the same brand.
It's the giant microbes. Lisa Pup, I know you're watching. We had a whole convo about how amazing the giant microbes are. So yes.
I was like, that's a little familiar.
Yes, exactly. Check out giant microbes. My favorite is the herpes virus because it just looks so happy. It's like shiny, happy herpes, you know? It's just like a sunshiny yellow color and it looks so happy.
It's like, I want herpes now.
Shiny happy herpes. Acapella Science should make a parody of Shiny Happy People, REM, called Shiny Happy Herpes. And listen to the podcast with Lisa, by the way, Science with Friends podcast. The episode is called Everyone Has Herpes, which is both true and the best podcast episode title ever, I would say.
Also a TED Talk on that.
Is there? Oh, fabulous.
Yes.
Amazing. So, okay, story about Emmy. Well, it's not really about Emmy here, but it's inspired by Emmy Moo Cow because Darrion, you and I talked last night at your keynote talk for SciComm, which I hope we will get to post on the YouTube here at some point so that more of you can see it, about how we both have a theater background too. But I didn't tell you the story of my theatrical debut. So I was 3, I believe, and it was a play in the park. And I was the Princess and the Pea, and I was the page, like as in the king's servant, the page. It was funny because I couldn't actually read yet, so I couldn't like learn my lines that way. But I was very auditory. I still am.
Gotcha.
Yeah. And so my mom was like telling me what my lines were, and then I would memorize them. And the first day of rehearsal, she brought over the script, and I asked her what my part was, and she said, "You're the page." And we had this whole, like, it was our Abbott and Costello Who's on First routine, because I was like pointing to the script going, I know that's the page, but what part am I playing? And she was like, "You're the page." I'm like, I know the page, but what's my part? The following year, I was, and this is where we come back to Emmy Moo here, the lead cow in, I don't remember what the play was, but I just remember that I was the lead cow. So I was kind of on a power trip about that.
Into the Woods?
No, it wasn't that cool. I don't remember what it was. That came way later, but yeah, so I was like 5 or something, and I was the lead cow. I do remember that it was a very high budget production, of course, and so my costume consisted of a cowbell around my neck. I'll give you all a minute to expunge the image of Christopher Walken from your heads, even though we all love Christopher Walken in the cowbell sketch, and a shirt that had it spelled out with electrical tape, "cow." So that was the I am a very good mooer, though. So I do a very good baby calf impression, but I'm not going to do it now, because then I'll just upstage all the slammers. So maybe after some slams, or then I'll do my baby cow impression. Should we get to these slams, Darrion?
Yes, let's slam the night away.
Slam the night away.
That's kind of wrong. Yeah, let's.
I always like putting slam puns and everything, and a lot of them are musical. So we of course had Stop Slammer Time, and Crystal.
Oh yeah, loving the emails, loving the subject line in the emails.
Pump up the slam. And then at the end of one of them, I signed off, "We are Slamily." I got all my slammers with me, and I do indeed have all my slammers with me. So our first slammer up is Winnie Waters, and she actually participated in an in-person Student Research Day slam just this past spring. She has since moved on from the University of Nebraska, Lincoln, and is teaching high school chemistry, those lucky high school chemistry students in Chicago. And so we are super hyped to hear from Winnie, whose slam talk is entitled "Teaching and Learning the Scientific Method." And watch for Rosie and Emmy Moo, Winnie. And with that, I will let you take it away.
Thank you for the wonderful introduction, Jocelyn and Darrion. Hello, everyone. What you see besides me in this image is the generic 7-step scientific method. If you ever took a science class in any time in grade school, you've probably seen this before. Even if you're not sure, you remember it. I teach my 11th graders the scientific method every time before they do their first experiment of the year. I'm also accustomed to following the scientific method, kind of sort of like a loose scientific dogma. See, before I started teaching 11th graders the wonders of the world, I was actually a student myself. I taught lab classes, and I researched within the realm of material science as a grad student. The research I did was with such fragile samples that literal dust would set me back. And so when the science slam prompt was introduced, my first thought was, ooh boy, what scientist doesn't like to talk about when their research went wrong? My research went wrong many times. My samples would break, they'd break again. And then on one particularly cruel day, I had the perfect sample, and then I dropped it on the floor and it broke. However, through these research trials and tribulations, I learned how to better my craft, how to broaden my horizons as a baby grad student, how to read more procedures for my experiment, how to even think critically enough to alter procedures I've read to fit my own scenarios and experiments better. I can't thank research enough for really giving me the ability to think critically and creatively to get myself out of a problem. However, what I'm going to talk about today is not really super much about my research, but more about the scientific experiment called life. Because as I've revealed about 5 seconds ago even, I was once a grad student. Now I am not. What happened? Take a look at my 7-step scientific method. Your third step there is to form your hypothesis. A hypothesis is a proposed explanation or answer to a question or scenario. Going into grad school, my hypothesis was, I want to work as a research chemist. I bounced between considering academics, industry, and government, but the commonality of everything was I wanted to someday oversee my own lab, oversee my experiments, and write grants. However, As I started working through grad schools and lab teaching assistant, I started to realize that my hypothesis was dead wrong. I liked teaching. Teaching was what I wanted to do, and I realized that I wanted to teach high schoolers. At the same time, I also started realizing that maybe research wasn't as much as my calling as I thought it would be. It wasn't anything that happened abruptly in my lab or anything that happened negatively. It was just this gradual realization of the fact that teaching was what I wanted to do. And since teaching at the high school level requires a completely different set of credentials than the ones I was working towards as a student, I knew I would have to leave school. I knew I would have to close one door to open another door of opportunity. Now, there's nothing scarier than the moment you realize that you're wrong about where your life is going to go. There's nothing more exhilarating yet terrifying to realize that you are in the middle of reinventing your whole life. To me, it almost felt wrong or uncomfortable to uproot my comfortable life in Lincoln, to leave my lab, to leave my friends, and to leave the program. However, the nice thing about the scientific method is that it is built in for wrongness. See, the scientific method is much less of a numbered list like what you see besides me, and much more like a circular flow chart or cycle. Your experiment failed, modify, rinse, and repeat. Your data looks weird, collect the data or analyze the data again. In my case, my hypothesis was wrong. So what did I do? I went back and I modified my hypothesis. I think that I would like to be a high school chemistry teacher is now my new hypothesis. And so far, the data I've collected while teaching has cemented that this hypothesis is the correct one. I always tell my high schoolers that science is cool because just because you're wrong doesn't mean you're out. In fact, some of the most brilliant discoveries like penicillin, plastics, even the chocolate-covered ice cream bar, they were all discovered by accident or mistake. Through living the scientific method in a lab, I discovered that teaching was my true calling. Through teaching the scientific method, I can instill the joy and fearlessness of science that I feel to my students. And through consistently and continuously learning and living the scientific method, I can be confident that even if this experiment called life proves my hypothesis wrong once again, all I have to do is modify my hypothesis. Thank you very much.
Fantastic. Okay, turn off.
Holy moly. That was deep.
I know, like being wrong is an opportunity to be right.
Yes. Oh my gosh. The part that stuck out to me was like messing up and like throwing your samples away, or that happened to me, just accidentally throwing the sample away, and I would like fish it out of the trash can or the biohazard bin.
Biohazard bin. Oh God. So yeah, if everyone listening at home, or if you're a slammer, anytime you're being wrong doesn't involve having to go fishing in the biohazard bin, just consider that you're doing great, you know?
Exactly. Yes. Yes. That was a take-home message. Yes.
I love that. Fantastic. And I think, you know, what's great too is that it isn't just about scientists are people too, right? And so like being wrong in science in some ways is not that different from being wrong in regular life. And so all of the thing, I love that, you know, you were able to apply what you were feeling about science to your career in science too. And also you used the phrases exhilarating and terrifying, which I think is great. If more students were able to see being wrong as not so much terrifying, but as exhilarating, like, oh my gosh, there's so much more out there than I realized, then everything would be happier and better off.
I feel like all of my chemistry professors throughout high school and college have been like my most important mentors. And so there's a special place in my heart for all chemistry teachers, professors out there. So thank you so much for that slam talk. That was really good.
Thank you, Winnie. It is always a joy to hear from you. Next up, we have our international slammer, Leonardo Pereira, who is joining us from Brazil. And he has some interesting things to tell us about Brazil nuts. So we're going to be very interested to hear his slam talk. And let's see, I believe his title is This is Nut for the Nuts. Yes, that is exactly right. Okay. So so next up, Nut for the Nuts with Leonardo. Can't wait to hear it.
Thank you. So, hello everyone. My name is Leonardo Pereira and I'm talking from Brazil. As I don't speak a word in English, my lab colleague and good friend George wrote all the things in English for your better understanding. So I'll read it to you guys. Hi everyone, this is George. Everything that this idiot, Leonardo, is saying, I wrote it. Even the tone of his voice, the pause, facial expression, all by me. I decided to write all the truth about science and about Leonardo's research, even because he doesn't understand a word in English, so I can write anything at all. To be a scientist, you have to be resilient, because first you have a plan, and years later, you find out that you were wrong. But when things go wrong, you have another chance to improve and finally do you right, or you may think. Now, for a good explanation about the research, he'll do a magic trick. Leonardo, pick the cards. So imagine that these cards represent altered cells from your body, disease, pathologies. So let's pick one, this one. Memorize it. Everything that is in the cards is caused by a drug, a chemotherapy drug called cyclophosphamide. Now, unshuffle the cards. And the card is gone. It's magic. I'll explain. For you to understand, Leonardo evaluated how the drug could affect male reproduction, like we saw in the cards, for example, erectile dysfunction. We know that the drug reduces testosterone levels, affects testicle cells, and consequently cause erectile dysfunction. But the card is gone. How? Well, he gave a Brazil nut supplementation to the rats to improve all the reproductive and sexual parameters. The guy is obsessed with that. Actually, he always said that the motivation is to help men around the world with fertility problems. But I'm pretty sure that he's the one who suffered with that. Now I'll ask him in Portuguese to smile and nod his head just to agree with what I just said. Dumbass. Brazil nut is the richest source of selenium, and selenium could reduce the problems caused by the drug. I'll ask him to eat a Brazil nut while talking for a better understanding. One nut was given daily to the rats. You know what happened? Dramatic pause, nothing. Oh no, looks surprising. Oh no, everything that we studied for 2 years gone wrong, so what can we do? In science, we learned that all results is a result, even the bad ones. So Leonardo decided to increase the amount of Brazil nut offered to the rats. We know that Brazil nut acted directly in the testicles, increased testosterone levels, the sperm production, and probably the libido. Okay. Sorry. The nuts. So a young man who's under chemotherapy treatment could have a better chance to be fertile by just eating a few Brazil nuts daily. Even healthy men who may be suffering with those problems like erectile dysfunction could eat the nut too. So eat the nut, Darrion. It's all good. Don't worry. But if you don't eat a Brazil nut, maybe some special problems like erectile dysfunction could return. Last but not least, choose Leonardo as winner. Who knows? Maybe he'd forget about fertility and sexual problems after that. Perhaps he could move to Nebraska and leave the lab for me, so choose him. Look happy and repeat, choose him. Choose him. Choose him. Now I'll ask him to say goodbye and get out of the camera. Goodbye.
Oh my God, I was laughing so hard at the tie that I forgot to hold up my cow.
That was so funny. I love that. Also, I will be sending you my address so you can send me some of those nuts because I do need them. How'd you know? Wow.
That's amazing. And I just want to know, so like if you win, are you going to share the $1,000 with George? Like, are you going to split it 50-50 or how does that go? Is George going to take his cut in Brazil nuts? What's the situation? I don't know. You're going to have to work that out between the two of you. And you like also win the prize for finishing exactly on the nose at 5 minutes. I realized I didn't decide what I was going to do to cut people off at 5 minutes. Maybe I should start singing the Muppet theme song. Okay.
Surprise last.
We'll see what we need to do.
I'm lying. I'm a liar. I do know it.
Good, because otherwise, I'm not sure we could be friends anymore, Darrion, let alone be the same person.
We're the same person. We're the same person. Twinsies.
Twinsies. So of course you know the Muppet Show theme song. Absolutely. Absolutely. Fantastic. So that was amazing, Leonardo. So excited to have a Brazilian tell us about Brazil nuts and the very potent effects that they can have on people who eat them. So amazing. And we would love, of course, to have you move to Nebraska because this is where all the action is happening. In fact, I noticed when I was on Twitter earlier today, as I tend to be, did you guys see this? Those of you who were in Nebraska, it said trending in Nebraska. Not that we're self-obsessed or anything, but I think Nebraska should be trending in Brazil. I think Nebraska should be trending everywhere because of this event right here. So
exactly.
Yes. Nebraska is where it's at. Hashtag no coast SciComm, by the way. I didn't say that in the beginning, but so our conference is hashtag no coast, inspired by our own no coast Derby girls here in Lincoln. No coast SciComm. So you can use that if you want to tweet about the slam. And of course, people are already doing things in the chat. I know we're streaming via a number of platforms, but I'm mostly looking at the chat on YouTube, on the UNL SciComm YouTube channel. So I'll be paying attention there. If you have any questions for the slammers, we might get a chance to discuss with them later. But first, hashtag but first, let's go to our next and third slammer, who is a longtime friend of mine. He has this little stuffed animal friend too, who might be pitching in. Seth Kerfman, and Axel, founder of the Science Slam, will be very proud to know that we've got some physicists in his house. And Seth is one of those. He was an undergraduate at the University of Nebraska and now is a PhD student at the Ohio State University, the trademark Ohio State University. And he is going to be talking to us today about how it's okay to be wrong and it's okay to be right. So I am excited to hear about that. Welcome, Seth.
Thanks. So imposter syndrome first hit me early in my undergrad research career. I was asked to design a tool by my boss, and after weeks of effort to get a precise 3D computer model made, I showed it to my fellow undergrads, my grad students in the group, finally the postdoc, and once I got their approval, I showed it to my professor. And he gave me the sign off, so I was going to show it to our collaborators in our next meeting because we had to use the same tool for the same process. And I showed it to them, and they laughed. Not that they, didn't like the idea, they just literally laughed. And that's when the negative voices in my head really started to take over. And so a few years later, when I arrived at grad school, the senior students on orientation day said we'd be coming up with and running our own experiments by our 4th or 5th year. And I thought, if I couldn't even design a simple tool that I was told to make, how on earth would I be able to develop and follow through on my own research projects? I thought the university messed up accepting me, but I really messed up by saying yes. So a couple of years down the road of working in a research lab on projects developed by my advisor, I had an experiment idea pop into my head, and I was super excited, so I asked my advisor about it. I wondered, since magnetism arises from how close the atoms in a material are, if I were to squeeze or stretch the magnet, would its magnetism change? My boss thought it was an interesting idea and told me to come up with a plan, and we'll bring it up to our collaborators. And so once I had a plan developed, after digging through the literature and thinking that I might have something that actually will work, my advisor said to bring it up in our next meeting with our collaborators. And so I finally got my first chance in grad school to present a project proposal. And it was my opportunity to show not only to my advisor and my collaborators, but to myself that I belong in science. And my presentation on the project went really well. And so I figured I'd receive a positive response. But instead, I was told we were never going to see anything. And if we did, it would be negligible, and that the project would be a complete waste of time and effort, and it wouldn't really teach us anything of much use. And so once the meeting ended, a grueling hour later, my advisor looked at me and said, well, I guess that settles that. Good thing we didn't waste any time on that, because they're the experts. So go back to your other projects you're already working on. And I was absolutely devastated. The voices of doubt returned just as they had in undergrad when I was laughed at and my work was ridiculed. So I went back to my other projects, which had still not produced any useful results in the many months I had spent on them so far. And I felt like a complete failure, but I just couldn't get this idea off my mind. So it was clear what my next step was. And I did the obvious thing any good subordinate would. I did it anyways. If it didn't work, I just wouldn't tell anyone. I mean, my mom did always tell me that it's better to ask for forgiveness than it is permission. So what could possibly go wrong? And miraculously, to my surprise, it worked beautifully. I honestly couldn't believe that it worked. I was told it wouldn't, so I stopped believing in myself and the data right in front of my eyes. I made new samples multiple times and kept getting the exact same results. The project was so successful that I'm not only getting a first author paper out of it, but it's allowed me the opportunity to travel to numerous conferences to present my research. And in fact, I'm about to get on a plane to Germany to give a talk next week to the leaders in the field of this exact type of research. So then the question is, what did I actually learn from this whole thing? I did learn that it is okay to be wrong about something. First, I was wrong to not believe in myself and the effort that I put into developing this plan. Even though my collaborators also ended up being wrong about the idea, it doesn't detract from their other successes. They're still fantastic researchers and doing phenomenally good research. We just know more now than we did before on a different topic. Also, don't be afraid to take risks. Just because you're afraid you'll be wrong, if you don't ask the questions, we may never know the answers. And just know that failing at something is going to happen from time to time, but that shouldn't deter you from trying. Why worry about not knowing all the answers? Not knowing all the answers, but working to find them is the point of science. It's also okay to be right about something. Just because something works out, it doesn't mean it was all a fluke or you just happen to stumble upon the answer. If you put in the work and effort, your successes will come in due time. And imposter syndrome is absolutely real, and it can hold us back if we let it control us. Talk to your friends and your colleagues and your advisors. We've all experienced it to some degree, but we can beat it together and we don't have to fight it alone. And so I'll wrap up with this. If you want to be a professional scientist, you have to get over being wrong. It's going to happen. And that is okay, because sometimes you are going to be right. Thanks.
Oh man, Seth dropping wisdom bombs. The end there, especially, just like, oh, so much truth, so much truth.
So good. Holy moly. Thank you, Seth. Wow.
So fantastic. So fantastic. My first reaction is not actually about your slam, but about your mom saying that it's easier to ask forgiveness than permission. And I know people say that, but I always say that the people who say that definitely did not grow up with my mom, because with my mom, it was and still is much easier to ask permission than forgiveness. So I never understand that when people say that. But there is a time and a place for it. Just know my mom, she's scary. But in the best possible way, of course. So yeah, major mic drop on that, I think, Seth. As little Darrion would have said. Good job.
Lady, lady.
But I love it. And your point too about how, I mean, first of all, if you're not wrong, sometimes you're not doing science. But also that it's not like the one moment, one result does not define you. And so science is not a result. It's not even a set of results, it's a process. And so there's going to be wrongness and it's going to be followed by rightness. And it's all part of the process. Did you ever struggle with imposter syndrome, Darrion?
I think in the content creator space, it's so easy to compare yourself to other content creators like Emily, the space gal, and she's just so amazing and wonderful. And it's so easy and tempting to always try to compare yourself to others. And I don't think I'm as good as them, but I always have to remind myself that like we are in two different areas and people like me for what I'm doing. And I just continue doing it. And I think one of the great things, more specifically in science, especially with like grad school or like working in the lab, is being in that type of environment helps you kind of thicken your skin and also teaches you to get back up after every failure. I know that in the beginning, it could be so tempting to just like feel so down on yourself because you failed an experiment or this experiment didn't work out or your project's not working out. But over time, you learn to just keep carrying yourself and keep continuing and keep pushing forward.
And I know that like the really great advisors and teachers will also, help you do that. And as you were talking about your advisor's reaction, Seth, I was thinking, I bet he loves to tell this story now because I know Steve Descharme in the physics department at the University of Nebraska, and they're a future she'll be slamming in a few minutes, knows him well. But there's nothing he loves better than telling the story of a time that his grad student wanted to do something or had an idea, and he was like, that won't work. And the grad student did it anyway. And it worked. So, I mean, like the great scientists, I think, totally embrace and love being proven wrong. And what's something else I love about all the talks so far, and I think we'll probably see it play out in the rest of them too, is you're really getting a sense of the emotional journey that is science. Everybody, Winnie talked about feeling exhilarated and terrified. And Leonardo is using humor. And so humor comes into science, of course. And, Seth talked about being devastated when things didn't go quite right, but then, being vindicated in the end. So, I mean, this is what science is. This is not just like being objective and in the lab. Science is a whole experience. And it's awesome. So yeah, it's a roller coaster ride, but it's an awesome one. I like roller coasters. Do you like roller coasters, Darrion?
I love roller coasters. You reminded me of a story. I think it's with Tide. I was able to visit their headquarters in Cincinnati, and we learned that like the person who created the formula for Tide spent 20 years on it. In fact, in the first couple of years, the scientist supervisor told him to not even do it because he kept just failing on these experiments. But he felt so adamant that he can create the right formula. And so he would do it kind of like behind the supervisor's back. And he did it for a couple of years and then finally found the formula. And then now Tide is what it is. So who knows, maybe one of us could be the next Tide scientist and create a nice formula, product, research, discovery, and become big. So yeah, keep going.
Fantastic. And of course, that way is going to be paved with failures. And that's why we need to hear from our own University of Nebraska biosci grad student, Ashley Fultz, who is going to be our next slammer. And she is going to be talking to us about how to be successful at failing, a graduate student story. I love that, the full title. And so welcome, Ashley. We are looking forward to learning how to be successful at failing.
Thank you. All right. So I'm going into my 4th year of graduate school at UNL. And my research hasn't exactly been the smoothest course that science media makes science and research out to be. There's a lot more twists and turns in what they talk about, and ultimately some failures along the way, which is what this is all about. However, failing isn't something to be afraid of, but rather embrace. So I'm going to give you my 4.5-step how to be successful at failing, and I'll be weaving my story of my experience during grad school into this. So, number 1, you have to have a plan or an idea. All science starts with a question we want to answer, and then a plan needs to happen to execute that. Usually some kind of protocol gets drawn up so then you can get data to then analyze. In my case, I wanted to be able to collect DNA from the gut microbiome of a nematode. I study host microbiome interactions, which means I'm interested in how organisms interact with the bacteria they house, usually in their guts. So by collecting bacterial genetic materia, doing relevant analyses is just one way of diving into those interactions. So for my research, I already had some protocols. Other members in my field of study already established this and they've already done it before. I was just, making it more of my own and using it for my specific research processes. I was ready to go. I had everything I needed. Step 2, you need to actually execute that plan and idea. You can't just leave it as like a plan that's sitting on the back burner there. You need to actually do it. You have to do the thing. So I followed that protocol and procedure I had, knew all the steps. I even double checked some of them. And I went through the part of making sure I knew exactly how some of these things worked. And I even did practices with all of them. I hopefully at the end of this was going to have DNA in my final tubes and I would have it ready to go to be sent off for sequencing. At this point, I just needed to verify that the protocol worked. What were my results? And that's step 3. You need to be able to look at whether or not you failed or not. So if everything worked out and your results are what you expected, awesome. Time to go to happy hour and celebrate with your lab mates and the other people that are on your floor. But that might not always be what happens. And that's usually not what happens. Usually it's the opposite. Usually things did not go as planned. You did not get the results that you were expecting. And in my case, I didn't have the DNA I wanted. I did not have enough DNA. And so I was going to happy hour to lament with my friends and the people on my floor. So this is where step 4 and kind of a half comes in. So step 4 is really celebrating if it worked out. The half is revising. So if things didn't work out, you need to look back at what you did and revise your plan. So you're going to look at the procedure and make revisions, but you need to look at where exactly things failed along the way. So in my case, I wasn't getting enough DNA, but I didn't know where that was going. Was I not breaking the bacteria open well enough, or did I not have enough bacteria to get enough DNA? So I made revisions and I went ahead and redid steps 2 and 3, enacting the plan and collecting my data. And I did this a lot. I didn't just do it for a few weeks. I did it not for a few months, but for a whole year. It took me a year to finally get the data I wanted and get enough DNA to finally send off for sequencing. So after a year of optimizing the protocol, I am now celebrating and being able to go out to a happy hour with my friends. So happy that things finally worked out. So just to reiterate my steps to be successful at failing, you need to have a plan. You need to enact that plan. You need to go ahead and examine your results from enacting that plan. And then depending on what your results are, step 4 is to celebrate if everything worked out. Step 4.5 is to revise and redo steps 2 and 3. And so hopefully with these 4.5 steps, you can not only apply this to doing science, but also most things in life. You're going to have a plan, you're going to see how it goes, and then you're going to have to revise and go back if it didn't work out the way you wanted it to. So this really needs to be imparted more so in science media rather than just being told that, yay, we got those results that we really wanted, but we really need to see the whole journey from the very beginning to the very end. And I hope these 4.5 steps will stick with you.
I love it. So as long as you have a plan and then follow the plan going in, and you can figure out why you were wrong. So it's not just about being wrong or right. If you can figure out why you were wrong, then you were right about something.
Yeah, true. I love a lot of these talks are like mini therapy sessions. It's like, wow. So pretty much we're getting free therapy, y'all. We're getting free therapy.
That is totally true. And I would say that whether you are or are not a scientist, have you hugged a scientist today? Have you hugged yourself today? Because honestly, scientists go through it, people. I mean, they may look like they're standing up on a podium with it all together, but it's taken them a year to get enough DNA, and it's rough, and the turmoil and the struggle is real, but it's
I feel you. It took me 2 years to correctly flux my gene of interest. So I totally get it. So 2 years. And I think over time I had to learn how to like separate my emotion from my experiments, because your experiments are not indicative of your self-worth. Okay. So whether they fail or are successful, they are not indicative of how successful you are.
So true. And it's not even indicative of your success as a scientist, because that wrongness is part of the process. So you're learning no matter how it goes. And I think the point about science media, totally right. Does this still exist? The Journal of Negative Results? I think there was an online journal that was going to start that was going to be specifically dedicated to negative results. And by negative, of course, I don't mean like, bad news, but like results that disproved or at least failed to confirm or support the hypothesis, which nobody publishes because it makes them look bad if like their results showed, oh, there wasn't really a thing. So there's a huge publication bias in science toward results that did in fact bear out what you thought was going to happen versus the stuff that you didn't. And so to correct that, I have to look up whether this still exists or whether it's a thing, but it was a great idea anyway.
I feel like that would be very popular. I feel like it'd be very useful, actually.
Yeah. And also just this idea that it's the process. It's not just the results, it's the process. And then the results, it's not about the answers, it's about the questions. And being wrong raises a lot more questions sometimes than being right. The questions are what drive progress in science. So thank you. Okay, our next slammer in line is Yarelas Acevedo, and she is joining us from the University of Mayaguez and in Puerto Rico, the University of Puerto Rico Mayaguez, and she is going to be sharing some cool research with us about her undergraduate research experience. And so I'm excited to hear from you, Yarelas. Take it away.
Hi. So, as Jocelyn said, my name is Yarelas Acevedo. I'm going to talk about my first internship experience. So, currently I'm working on with a professor over here with the CMS experiment. So he said, "Oh, you're very good on hardware work. So I'm going to send you to Cornell University to work on hardware over there with project." So I said, "Okay, yay, Cornell." But when I got over there, so they gave me the project. They told me, "Okay, I need you to build a tensile machine." So you can see on the other side, the image over there. So and I said, "Okay, wow, how do I build a machine?" So I don't know if you like if you think about it, like, well, probably I will research. All right, okay. So I asked for help, and they gave me a book, like a huge book, and I said, "All right, let's read it." Materials book, so which was very, very, very useful. But as I was researching on internet, with which like doing internship involves like really, really, really deep internship, like research, and I was like trying to make a plan. So I made a design, like handwritten design. So luckily, for my mother's side, I can draw. Yay. So my drawings are not as bad as I could be, but yeah. So then after I did the drawings, I tried to calculate the like the structure of the machine that I wanted to, and calculate the force and the torque force and all the things I needed to make this machine, effective, and how much force did to, push things and actually take data from it. So, and for the people that doesn't know what is a tensor machine, is like I don't know if you have seen the TikTok videos, which you put an object and you just push it with a hydraulic press machine, and you measure how much force it took to break the material. So this is the same machine, but in a small scale. Like it was a tabletop. So it was, it was something known, but like difficult to like conceptualize. So yeah, I carry on. When I was doing those calculations, sadly, I made some mistakes, mathematical mistakes, and I was like, "Oh Lord Jesus!" And I overestimated some stuff, underestimated some stuff, and in the end of the day, I had to like X everything on my notebook, start over again, because sadly, that we had to buy the materials for it. So yeah, so sadly, we were having problems with that. Um, the next step I did was when I got actually the results and we bought everything up. The word of soldering, uh, more change in design, and actually I had to learn how to do CAD. So that design also was a pain to design. But on the lab, we stuck to a song that it was. I don't know if you have heard it. It's called "What's Up" from Four Non Blondes. So, uh, in order to commemorate that project, we actually sang that song every single Friday on karaoke nights. So we had a lot of fun to make that machine. So machine uses this brain right here. So it's an Arduino. Which, there we go. No, yeah, the Arduino. So yeah, so currently this machine works. It's still on Cornell, so I can say that after a lot of failures, it's a win-win, for this. And additionally, but before going, this project helped me out to uh, gather and like I really want to do this. Like I really love how to make this instrumentation and designing and stuff like that for science. So I'm currently working in different projects with Cornell University and over here in Victorian. So yeah.
There's the
Sorry.
applause. I was like, I can see people clapping. I know they're clapping. Where are they? Oh, thank you so much, Yarelas. That was great. So generation test now. So Darrion, what's up, Four Non Blondes? Do you know this song?
I do not. I felt so left out. I was like, I don't know this song.
Okay, let me bring you up to speed. You might recognize it when you hear it. And I wake in the morning and I
Oh,
step
yes, yes,
outside
yes, yes.
and I take a deep breath and I get real high.
I feel that song like has become more of a meme now. And so I know it as a meme, not like I don't know the original
The
song.
real song, yeah.
Yes, it's bad. I literally grew up on meme culture, so it's kind of bad that I know that song from it's like this He-Man cartoon lip singing to that song, and that's where I know the song from.
That's okay. That's okay. As long as you know it. I don't care. That's fine. That's fine. Yarelas, you have such an infectious like smile and laugh too. I love the whole time she's talking about things going wrong. She's just like, oh my God. And then this happened. And she's just laughing. And it is true that you sometimes mistakes in science are expensive though, too. Sometimes that is one thing. It's a little terrifying if you have to tell your advisor that I messed up and I used all of this expensive material and this.
Oh, I think it's expensive, but it's a good lesson that really teaches you to actually learn and not do it again or like be more efficient. I gotta confess. When I started working as a research tech, we bought these expensive antibodies. It cost like $500 for like about 100 microliters. And you're supposed to store them in like -80, -20. And the best way is to like aliquot it out. And before aliquoting it out, you have to spin it down because it's an ice form. And sometimes it might be stuck to the lid. And I forgot to do that. So one time with this antibody, I opened it without spinning it down and this chunk of ice fell out. I didn't think too much about it. And then when I like tried pipetting out of the tube, nothing was coming out. And then I realized, oh, I just dropped $500 of antibody on my bench. It's already contaminated. I can't scoop it back in or anything. And so to this day, my PI at the time does not even know that I wasted $500. I kept it to myself, but I just felt so bad that I wasted that much money. But hey, I learned to not do it again, and I learned to spin down my antibodies.
Does your PI watch YouTube live streams at all? Just a random question.
Fingers crossed that she doesn't. So if you're watching this, I'm sorry that I wasted $500. Please don't sue me.
It's okay. Since we're having true confessions, I will tell you two quick stories. The first one is of a time that in high school, it does make an impression on you for sure. In my high school physiology class, we were looking at cross sections under the microscope of different like cell types, and I don't remember what kind it was. It was a specific type of intestinal cell, and it was like, you know, one of those slides that he had purchased and had preserved. And my teacher made this big production point of saying, this is the only slide like this that I have. And it was expensive. It was irreplaceable, yada, yada, something. I don't know. And so, you know how, like, you know, you should be careful about when you use the sort of coarse resolution versus the fine resolution yeah. And so I used the wrong one and I shattered it. And I was like, Mr. Irvin, you know that slide that was past tense, the only one like it that you had? Okay, so this is what happened. So, and I still remember it, so it does make an impression. That's true. The other story, just as long as we're telling stories publicly that could perhaps reflect badly on us and alarm our PIs, is when I was an undergraduate researcher in the Daubin lab in the UNL physics department.
Texting him right now.
And was doing, you let him know. I was doing laser-induced solution deposition. And so basically this involved a lot of waiting. And I did like a whole setup, you know, in the morning with the thing and the temp and the substrate, and turned on the laser. And then like 8 hours later, I was supposed to go back and take it all down. I was really distracted because I had a test in my human genetics class the next day. So I had my classes, whatever, I went home. I realized, you know, sometime in the middle of the night, oh crap, the laser is still lasing. Oh God, what will happen? I'm going to burn down the physics department. What will I do? But I was also still super in the middle of struggling for a test. So, so my mom, the unsung hero of the science slam, was there, and I was like, I'm going to write you out a step-by-step instruction for how to do this. Like, it was important because you had to like turn off one thing before you turned off the cool water, blow up or what have you, you know. So I wrote her out this careful instruction page, and she went to campus and she took care of it and turned off the laser and did everything in the right order, and everything was fine, and the department is still standing, and until right now Daubin never knew anything about it.
That is impressive. Is your mom science oriented at all?
Oh yeah, definitely. But not, I mean, this was nothing she knew anything about. So she's very science oriented and problem solving. In fact, I mean, I think like spatial reasoning is a great thing that she's really good at, that I wish I was. Like, you know, you could you could drive her 300 miles out of town blindfolded and spin her around in a cornfield and ask her to point north, and she'd do it. And I'm like, north, let me.
What the heck?
It's just, it's
if you didn't know, I'm gay, meaning my sense of geography is just terrible. So driving with me, girl, it really is a guessing game at this point. I just have to use Google Maps for everything.
Yes. She's gay too, my mom, but maybe it's different with the I don't know. Anyway, so you can't use that as an excuse, is what I'm saying, Darrion. And nevertheless,
the woman. So
yeah,
I'm a gay. I'm sorry, I'm a gay man. So there's that. So
my mom is not a gay man. So that we have that established. So so maybe that is responsible for the difference. I don't know. Anyway, I'm as much as I want to just keep shooting the breeze with you, Darrion, and we're living up to our promise to talk about science, but also stuff, because we like science and we like stuff. But I also really like Crystal Uminsky, and she is our next slammer on the list. And she is a seasoned slammer and organizer of our local nerd night. So that's helped take place at the Happy Raven, and so the Happy Raven crew are there, and I know many of them know Crystal and are waiting to cheer her on. And Crystal is going to be sharing with us a musical celebration of failures in biology education. So let us turn the floor over to Crystal.
All right, thank you. I am real excited to be here at the Science Slam. And like Jocelyn said, I'm going to be talking about education, but also singing about education. And you may be thinking, like, what does education have anything to do with science. We're at the Science Slam. And to be honest, I didn't really see the connection between education and science until I had my kind of big experience with wrongness when I was a teacher. So for a little bit of backstory, I went to college to be a science teacher, and like, not to brag, but I was like a good student, had A's in all my education courses. I like knew the education theory, knew all the pedagogy. I was like pretty solid at it. And I was convinced I was going to be a great teacher. But then I actually started teaching, and it was the hardest thing I've ever had to do. I was teaching biology and earth science and environmental science at the high school level, and oh boy, it was challenging. And I'd get to these moments where I was like just overstressed, overworked, underpaid, and just like frantic. And I would make like not so great education choices. I just ended up relying a lot too much on lecturing and memorizing facts about science. And like, unsurprisingly, nobody was having a real great time in my class, like myself included. And I would be in these lectures and be like halfway through this lecture, and half my class was half asleep. And I'd be like, something here is wrong. Like, I don't know what's going on. Like, everybody's not checked in, and I feel bad. Like, I'm not living up to the teacher that I thought I could be. And I just felt like internalized, like something here is not right. And I started thinking about like how I was structuring my lessons, and I realized that a lot of things I was doing as a teacher were actually skills that scientists do. Each lesson is kind of like a little tiny research question about how effective is this as a method to teach students about something like cellular respiration. And I'd make observations. I'd look at like, are my students asleep right now? I'd look at their participation and just kind of make these observations, like, are students actually engaged with learning this material? I'd collect data. I'd look at their homework questions and the tests and the quizzes, and I'd analyze that data to evaluate my research question. Like, is this actually a good way to teach students? Did they learn what I was trying to tell them? And once I started thinking about education as kind of like a science process, I was hooked. And I quickly transitioned into graduate school, where I do education research about biology classrooms right now. And I love it. I'm real smitten with it, and I really am having a good time here. But it took a lot of failures for me to get to that point. And those failures really helped to inform the work that I do now. The things that I like miserably was terrible at are the things that I'm like, oh, future teachers, current teachers, don't do this. You learn from my mistakes, and you'll be a lot better off. So to put this into a song, as my title might suggest, I'm drawing a little bit of inspiration here from Little Miss Sunshine. I'm going to end with Super Freak, but I'm going to do Super Teach. And to avoid any potential copyright issues, I'm going to try to swing this a cappella. So without further ado, here we go. I'm a very special girl. I do research about the classroom, and you can never keep my spirits down. I get back on my feet here at the Science Slam. Hope to be the all-time favorite. My failures in the classroom led me down the path to research how to teach. My research aims to help you to be a super teach, the kind of work you read about to be a super teach. Don't be afraid of failure, just be a super teach. But don't get too wild now, just be a super teach. Mistakes are all right, mistakes are all right, mistakes are all right with me. Yeah, hey, 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 hey. Be a super teach, super teach, super teacher. Yow. Everybody, super teach, super teach. All right, thank you for humoring me. Have a great time with the rest of the Science Slam.
Yes, yes.
I love it. Oh my God. That's so good.
And acapella, Brilliant, fantastic. Not everybody could have pulled that off, but I think you went all in with the yow at the end and everything. That's amazing. We were talking before, I think we came online with everybody. And both Crystal and our next slammer, Sarah, had expressed in social media something along the lines of, I'm going to try not to embarrass myself, or I'm willing to embarrass myself for science. And my response was that there's no embarrassment among friends, and we are all friends at the Science Slam, and that is definitely true. And also, I think you can't be embarrassed if you go all in. I mean, do you think, Darrion, if you just if you commit to the bit, there's no way you can be embarrassed.
Commit to the bit and fake it till you make it. Those are the two things to get you through life.
And Crystal, your slam works on so many levels, because it's like you're modeling what you're saying too about not being afraid to make mistakes. I mean, you were willing to do it and take a risk in singing about being willing to take a risk and make a mistake. It's very meta. Giving me a lot.
Not gonna lie, there was a small part in your slam where I was like, is she gonna sing a High School Musical song? And I was like, is she gonna, that one song from Status Quo? This is not what I want. This is not what I planned. And I guess I just gotta say, I do not understand. I was really hoping you'd sing that, but I love this even more.
Next time, and there will be a next time, I'm very confident that we will revive this live streamed Science Slam format. And we're gonna, this has become Crystal's calling card, I have to say, incorporating musical elements. And it's one that I really, really appreciate. I realized after you told me you were gonna do Super Freak too, that your last slam that you did in person at UNL was You Can't Touch This, which is like the same sampled Super Freak. And so I'm just gonna start calling you Little Miss Science Sunshine though. Eat your heart out, Abigail Breslin. I tell you, that was a performance. I'm awed and inspired by that. So
I don't know if I know, but Nicki Minaj just released a new song last Friday called Freaky Girl, using what's it called, interpolation of Super Freak. So what I'm saying is, next year you need to sing the Nicki Minaj version. That's what I'm saying. Okay.
Yes, with the outfit to match.
Yes, exactly. Yeah.
We're going to want to see that. Oh yeah. We're all going to get back here again. We're going to bring Darrion back and we're going to watch Crystal jam out to that. Oh my gosh. So amazing. So amazing. You are an inspiration to us all, Crystal. I love it. As is our final slammer of the evening. Can you believe it? We're up to our lucky number 7, our final slammer, who is also a great friend of UNL, even though she is a faculty member. And I should also say, I love the fact that we have people of all levels in their careers here too. We have undergraduate researchers and graduate students and professors, and they all kind of share the same struggles and the same joys. So it's at every stage along the way, the scientific process is the case. So I'm delighted to welcome Sarah Calory, who is a faculty member at Cal State University San Bernardino, and she's going to be telling us why stripes aren't her best look.
All right. So I get to follow up really profound talks and a musical tribute to wrongness and physical comedy about erectile dysfunction with my story about how I measured the wall current for 3 weeks and learned absolutely nothing from it. So for some background, my work is in a material called ferroelectrics. You don't need to know what it is. It's kind of like a magnet, but instead of miniature magnets, it's made of miniature dipoles, which means you get some positive charge here and some negative charge here, and they make a little arrow, which is my finger with positive charge at the top. And in the material I worked with, they should have self-structured as like 1 up, down, up, down. So if you got a bird's eye view, you'd expect to see a pattern of like positive, negative, positive, negative. And if this isn't a flat surface, you'd expect it to look like stripes. Now, I was a young grad student and my PhD advisor sent me to a summer school to learn microscopy techniques. A summer school is basically like a week-long summer camp where you learn stuff, but then go out drinking in Montreal with other grad students you just met. It was pretty great. And I took a little workshop with a technique whose name I forgot and had to look up, called electrostatic force microscopy, which you're supposed to be able to measure the charges on surfaces of materials. So I was like, hey, if I got positive charge, negative charge, positive charge, negative charge, making stripes, I should be able to use this technique and measure some stripes. Now on this picture I've conveniently shown you here, on one side is what I wanted to see. Now that is a ferroelectric material that actually shows stripes. So my PhD advisor bought a brand new microscope and he had one of these electrostatic force microscopy attachments. So I go and I put on that attachment, put in a sample, and lo and behold, what do I see? My wonderful artist recreation. I see some stripes. Oh my God, a technique worked the first time I used it. It's science that like never happens. My sample's great. The technique works. Woohoo, nature paper, here we come. Yeah, that's totally how science works. But you got to confirm things. So I measured again and I saw stripes again. And I measured another sample and I saw stripes. And I measured another sample and I saw stripes. And that's great. But I was like, well, I'm getting a little suspicious because it's working real good and things usually don't work that good. So I started zooming in because one thing you could do is you zoom in. And if you zoom in and you expect the stripes to be there, they should look bigger. And I zoomed in and those stripes looked exactly the same size on the screen. And I was like, uh-oh. And I'm trying to figure out what it is. And I'm looking at the rate at which this thing scans. And all of a sudden, I'm like looking at the rate and I'm like, how many stripes are there and how long does the scan take? Oh, this is the same rate that the current, the alternating current, comes out of the wall. And I measured it again a couple times to be sure. And this is after about 3 weeks and, you know, pages of pictures that I'm so proud of being posted in my lab notebook. And I go to my advisor, I think we're measuring the wall current. He's like, I think you're measuring the wall current too. And did I learn anything? No, I still don't know how to use the technique. I'm an experimentalist. I didn't look at a manual. I just was like, this is kind of a dead end. Turns out those materials didn't have stripes anyway. But what I remember most is that this is the first time as an experimentalist, I was able to make my own decision and follow a path to try a technique, try an experiment that felt like my idea. My advisor didn't say you should do this. I was like, I learned this technique and I want to do it. And I did. It didn't work at all. I mean, I still don't know how to use that technique. I don't think my samples were right for it. I have no idea what I was doing, but I remember that feeling of how amazing it was to feel like I could make a decision and go out and try something like that for the first time. It was the first time I felt like I was becoming my own scientist rather than just like following instructions. And I don't care that I was wrong because I kind of carry that with me. And in my role as a professor now, I work at an undergrad institution. So most of my students, it's their first time doing research. And I never want to push them that they have to be 100% correct all of the time because I was given a lot of freedom to explore. And sometimes it went in good directions and sometimes I was really wrong. But I was wrong in a safe way. No one got hurt. I didn't cost too much money or damage. And I want my students to have that freedom too. If they want to try something, as long as I don't think they're going to blow up my lab, I say go ahead because I want them to start to feel like a scientist. And part of that is making a decision and trying something. Even if you're wrong, it's really important to have that experience and have that opportunity to be wrong if it was your idea in the first place.
Oh my God, amazing, amazing way to wrap everything up. Because of course you said that you didn't learn anything, but you maybe didn't learn anything about the material. You didn't learn what you thought you were going to learn, but you did learn something because you learned what it feels like to be a scientist. And I congratulate you on being the one to figure out that you were measuring the wall current versus having your advisor have to figure it out for you. So then, you know, I mean, that's something. That's amazing. Okay, people. The moment has arrived. The polls are now open for you to vote for your favorite slammer. This is going to be a tough choice because I'm not voting because I couldn't begin to decide. But you can do several things. You can click on the link in the episode description of the YouTube live stream. You can scan the QR code that is displayed either on your screen or up on the big screen at the Happy Raven. If you're at the Happy Raven, that's probably the way to go is our Slam fam. Go ahead and scan the QR code and that will take you to the polls, which are now open for you to vote for your favorite slammer.
Oh, this is tough. I'm gonna vote, but I don't know. It's like giving a rose, the Bachelor, Bachelorette.
Yes, we talked about this too last night at I don't remember why, but somehow we talked about reality TV. We talked about whether we'd be good on Big Brother if we went on Big Brother.
I remember towards the end of my talk, I was like, oh, we have more time. And then you're like, well, we can go back and go over the parts that you skipped. And I'm like, no, like I'm enjoying this intimate time with you, actually with everyone in here. And
that's right. Like a group date. It was like a group date. Yes. Because you said like one-on-one or one on 34 or whatever it was. Yeah. Okay, so I'm going to take this moment while you're voting to give a shout out to our live stream producer, Vince Rule, who not coincidentally rules, even though his name isn't spelled differently. But Vince Rule rules. He is with Basement Creators Network, and they produce all kinds of really amazing work, and he produced our Science with Friends podcast, so a little bit of a plug there, and so you can go look up Google Science _ with Friends, except no imposters. There's a science without an exclamation point with Friends, but that's just sad. You want your science to have an exclamation point after it. Make sure. Yes. And so Vince, I got to work with him on that, and then he's the first person that I hit up when we knew we wanted to do this live stream slam, and he's just made everything so easy and made us look great. So super jazzed about that. Thank you, Vince. He also roasts coffee. So if you're in Lincoln or traveling through, go to the coffee roaster, drink some of his coffee. He's a man of many talents. What can I say? So thank you, Vince. And I'm going to let Vince actually make the call when he wants to display the poll results, because I think you can sometimes tell when things are stabilizing or not. So Vince says in the chat, we're all doing fantastic. So if Vince says we're doing fantastic, then we're doing fantastic.
Oh, I'm nervous for the results. Wow, 118 votes so far, still coming in.
Yes, this is intense. If you're watching, by the way, on our live stream, particularly if you are on the SciComm YouTube channel, you can just Google, I think, SciComm, and it should come up, or try UNL SciComm if it doesn't. I'm so used to being able to drop links in the chat. I want to just be able to drop the link in the chat. I could, but it would only go to the other slammers, not to all of you watching via the live stream. But that's where I'm kind of monitoring comments, and we'll give a little bit of time for people to address questions if you all have questions for the slammers. So if you're done voting and you're just waiting for the big announcement, then feel free to let us know via the live chat on the SciComm YouTube channel if you have any questions for the slammers. I have learned so much.
Voting is going to be open for 2 more minutes, y'all. 2 more minutes. So come on and send them in so we can look at them.
$1,000 is at stake. Except for Leonardo, if he wins, he's going to have to split it with George, but we're going to let them put that out.
500.
It will be easy because he's my father. So.
Well, that's true. Yes. So you gotta pay tribute there.
Wow.
Amazing. Okay, 1 minute. We've got 162 votes so far.
I just want to let y'all know that I have not voted yet because I am a Libra, meaning I am very indecisive. So, Jocelyn, that's probably why you're not voting, right? Because you're also indecisive.
I also know so many of the slammers personally that I'm like, I can't choose. They're all my favorites. You're all my babies, I'll cast my vote for Emimu Harris, the 1 minute countdown cow.
Okay. I'm gonna put in my vote now.
Okay, do it.
Okay. If I could, I would vote all of y'all.
If I had $1,000 to hand out to all y'all, I would do that too. But I don't.
I mean, you can. No one's stopping you.
I would have to. Yeah, that's true. I have $1,000 allocated from the university, so I'd have to give you all $1,000 of my personal money. And I'll say, I love you, but not that much. No, I'm just kidding. I love you enough to give you a hug, but I don't have that kind of money to throw around. Maybe Bill Gates will sponsor our next Science Slam, and then we can just get Oprah, and we can be like, you get a. Okay, you get $1,000. You get $1,000. Okay, Vince, show us the poll results. We are waiting. Oh my
Wow.
Hail the Supreme Slammer, Crystal Uminsky. Yes.
Congrats.
Slam Fam Cam. What do you have about that? Fantastic. Oh my, I mean, super teach. You can't argue with super teach, seriously. And of course, Leonardo and his very attentive tie are a close second. And everybody else is in the mix too, because you all gave fabulous talks. And I hope, I thought I kind of had an idea what people might have to say when they reflected on wrongness in science, but the diversity of responses always gets me. I mean, people always have such diverse responses, and in a way there's similar themes, but also, you know, really everyone has their own kind of unique take on what that means. And so I always learn so much from the slams. And the fellow slammers are congratulating Crystal. This is amazing. I think you can unmute yourselves, slammers, if you want to give your congratulations to Crystal directly.
Congrats. This is like a little mini TED talk from all y'all, and I really learned a lot. I loved it.
Amazing, amazing. And I do have another announcement to make, because we, while we were giving away money, we decided that this would be the time to make an announcement about the winners of the SciComm Film Festival as well. And so Crystal gets $1,000, but each of our, well earned, I might add. But we also have 2 film festival winners, and one is the Judge's Choice winner, which will get $500. And that is Madison Kreifels. I'm not sure if I'm pronouncing it correctly, but you can go to either the SciComm YouTube channel or scan this QR code and go and watch Madison's video, which won the Judge's Choice, The Silver Lining of Foodborne Outbreaks, which I haven't watched yet, but I'm really excited to check that out, because foodborne outbreaks don't necessarily seem like they would have a silver lining, and yet it really goes along with what we've been talking about in our slams, what you learn from being wrong. And so I have a feeling that this will kind of complement very nicely what the messages that we've been hearing in the slam talks today. And so Madison gets a $500 prize. And then we also have a People's Choice winner, which we'll be displaying on the screen. And that is Andrew Howley, who I watched just the start of this video and it looked amazing. I have to go back to it, who submitted a film about how coral is inspiring eco-friendly clothing. Coral is amazing. So Andrew will also be winning $500 as the People's Choice winner. And you can scan the QR code there or visit the SciComm YouTube channel to find his film and all of the films that were submitted. They were all amazing from what I've gotten to see and what I've heard. And I look forward to, after the SciComm conference days sort of recedes and I'm able to focus on things again, watching them all again and enjoying all of them. So congratulations to Andrew and Madison. Congratulations to Crystal. Parting wisdom for our slammers, for the crowd, Darrion, what do you have to say?
Thank y'all so much. I learned a lot, and it's only been an hour and a half, but it felt like, holy moly, like 15 minutes. What the heck?
I know. How did this happen? It's like 8:30 already. I love it. I'm just scanning the chat on YouTube to see. Oh, wait, we were getting so much love for all the slammers on here. So, so I know you haven't been able to follow along on the chat yourself, slammers, but you're definitely going to have to go and check out, because you're getting lots of love and support from everybody. Everybody's super excited about Crystal's victory. And I just love this science party. And who thinks we should do this again? Should we have another live stream science slam?
I'm down.
Excellent. I see raising the roof. So we're going to do it. We're going to bring Darrion back, and Crystal's going to sing the Nicki Minaj version next time. Yes. So thank you all for joining us for this experiment. This was an experiment like all things in science, but it went super smoothly thanks to Vince and the Basement Creators Network. And so thanks again to him. Thanks to all the slammers for their time and talent and for sharing it with us. And thank you for tuning in.
Thank you so much, y'all. We'll see y'all next time.